Alright, so this is part 2. So we're going to pick up where we left off with finding the area of quadrilaterals and triangles on the coordinate plane. Alright, so here we go with number 7. So quadrilateral with these vertices. So let's graph that and see what we got. So it should look like this. So once again we're finding the area, so we need to figure out what lengths we have. Okay, so if I'm using the distance formula, pick a y value 3 minus a y value 10 squared plus an x value negative 6 minus another x value negative 4 squared. So negative 6 plus 4 would be negative 2 squared, plus 3 minus 10 would be a negative 7 squared, so positive 49 plus 4 would give us a 53. The square root of 53 is about 7.28. Okay, and we try another side, so 10 y value minus 8 squared plus negative 4 minus 3. So negative 7 squared plus 2 squared. Okay, 2 squared will get us 4. Negative 7 squared, 49. Should notice we're getting the same thing, aren't we? So that would also be 7.28. So most likely we're dealing with a square here, aren't we? Let's see if we would start out for this one. So 8 minus 1 squared plus 3 minus 1 squared would give us 2 squared plus 7 squared, which is essentially the same thing, 49 and 4. So yeah, this has to be a square. Last one, 3 minus 1 squared plus negative 6 minus 1 would give us 2 squared plus negative 7 squared, which would also be 7.28. So I go 7.28 times 7.28 to get the area for this one. So 7.28 times 7.28, about 52.99, so probably close to 53, which if we look at that, yep, 53, not the square root of 53, 53 units. Alright, let's take a look at number 8 now. So for this one we've got another quadrilateral. So we start off here, square root of 4 minus 7 squared plus negative 7 minus 1 squared. Negative 7 minus 1 is negative 8 squared. 4 minus 7 is negative 3 squared. Negative 3 squared is 9. Negative 8 squared is 64. So it would be 73. So the square root of 73, which is about 8.54. Okay, now we do this one, 7 minus negative 9 squared plus 1 minus 7 squared. That's plus 7 plus 9 is 16 squared, plus 1 minus 7 is negative 6 squared, so 36 plus 16 squared is, not that number, 256. Plus 36 gives us 292. So we take the square root of that, and we get about 17.09. Okay, for this one. Now we do the next one down here. Square root of negative 9 minus negative 12 squared plus 7 minus negative 1 squared. So that's 8 squared plus negative 9 plus 12 would be positive 3 squared. We saw an 8 and a 3, so this might be a rectangle, huh? 9 plus 64, which would give us 73. So yep, so chances are this one's going to give us the same thing. Let's do it right here. Square root of 4 minus negative 12 squared. That would be 16 squared, which is what we had here, plus the x value, negative 7 minus negative 1, which would be minus negative 1 would be like plus, so it would end up being negative 6 squared. So yeah, so we've got a rectangle. So our two lengths are 17.09 times 8.54. So 17.09 times 8.54 gives us 145.94 units squared, which would be about 146. Alright, so now 9 and 10, we're dealing with two triangles here. Alright, so our triangles. Let's take a look at those. So here's our first triangle. Okay. Now the problem with triangles is we need to find this height and this base. Okay. So the base would be easy. We just find the distance of that point AC. So I go 1 minus 4 squared plus 1 minus 9 squared. So we get negative 3 squared plus negative 8 squared. So 9 plus 64, which would be 73. So we just did the one like this, right? So the square root of 73 was about 8.54. So our base is 8.54. Now the problem is, we need to figure out what this point is right here so we can find the height. Okay? To do that, we need to find a line perpendicular to this line that passes through this point. Okay? So now this line here has a slope of 1, 2, 3. So up 3 over 1, 2, 3, 4, 5, 6, 7, 8. So it's got a slope of 3 over 8. We need the opposite reciprocal. So it would be negative 8/3. So then I go y minus y1, which y1 is 7, equals my slope, negative 8/3, times x minus x1, which is 5. Okay. Then I distribute negative 8/3 times x plus, because negative times negative, 8 times 5 is 40/3 equals y minus 7. Then we would add 7 to both sides. When I add 7, I think of 7 as 21/3, because then that gives me the same denominator. So we get y equals negative 8/3 x. Then that would be plus 61/3, which 61/3 is basically about 20 1/3. Okay? So if you wanted to, you could think of that as 20.333. Alright, now I need to find out where they intersect. So this equation, we need to figure out that equation too, don't we? So we would go, this 0.11 seems easier. So I'd go y minus 1 equals our slope, 3/8, times x minus 1. So we get y minus 1 equals 3/8 x minus 3/8. Add 1 to both sides, and I think of that 1 as 8/8. Okay, so we get y equals 3/8 x. Negative 3 plus 8 would be a positive 5/8. Now, to find where they intersect, we need to find that point. So I take this, and I set it equal to this, and it's ugly. So I get 3/8 x plus 5/8 equals negative 8/3 x plus 61/3. Okay? Now, honestly, I think the easiest thing to do here is to multiply, well, I don't know if that's the easiest, but if we add 8/3 to 3/8, that's not going to be very fun. So if we multiply everything by 24, because 8 times 3 is 24, okay, this would be 8 times 3, right? 8 times 3. The 8 would cancel. 3 times 3 would give me 9x plus the 8's cancel. 3 times 5 would be 15 equals 24. That's like 3 times 8. So the 3's cancel. Negative 64, because 8 times negative 8 plus 3 times 8. That's what 24 changed to. Whatever 8 times 61 is. Which is 488. So I add 64 to both sides. That gives me 73x. Subtract 15. So 88 minus 15 gives us 473. Divide by 73. And we get x equals, x equals about 6.48. Okay? Then we got to use that to figure out what our other value is. So I would go 3/8 times 6.48 plus 5/8. See what that equals. And I'm just going to type that just like that in my calculator. So I go 3/8 times 6.48 plus 5/8. I don't think I'll give you one like this on the test. These are nasty. So the y value ends up being 3.06. So we did all of that for that one point. So 6.48, 3.86, I can now use that with this point to find out what our height is. So I go 7 minus 3.86 squared plus 5 minus 6.48 squared. And I get 7 minus 3.86 is 3.14 squared plus 5 minus 6.48 is negative 1.48 squared. Okay, 3.14 squared is about 9.86 plus negative 1.48 squared is about 2.19. Add those together, I get about 12.05, which we take the square root of that, and we get 3.47 for our height. A lot of work just for that number. Then I use the area, so area equals 1/2 times 8.54 times 3.47, and I type that into my calculator, and we get an area of about 14.81 units squared. Now, as we see, we don't have anything that says 15 here. So we must have been slightly off doing all those things, so I would guess that's the closest one. I'm not going to give you guys one like this on the test, so don't worry too much, because I think I'm going to have to do it for number 10 as well. Apparently, we should have checked this. That's a right angle. This could have been our height. You would have came up with a distance about 7.21, and this would have been our base, and it would have been 5. 7.21 times 5 times 1/2 gives us 18. That one could have been a lot easier. Guess we should always double check to see if it's a right triangle. So if we look at this one, we'd want to double check to make sure these are not right triangles. So I'd make those triangles, and we'd use those to measure our pieces from those vertices. Actually, let's do that. Okay, so here would be 2 and 3, so that would be a distance of 5. Then going down would be negative 5. Okay, then on the other one we'd go down 10 if we counted, and then we'd go to the right 4, and here we'd go over 1 and up 5. So slopes would be 1/5 for this one, negative 5/5, so negative 1 for that one. These are not opposite reciprocals, so I know that that's not a 90-degree angle. Okay, then negative 10/4, which would reduce to negative 5/2, which they're close, but not quite. So we don't have any 90-degree angles, so we're going to have to go through that whole darn process again. Okay? So the way I would do this is like this. I would go from this point to here to find my perpendicular line and have that be my height, to have this be my base. So I'd first start off by finding that distance. which I can easily do without using the distance formula by using the Pythagorean theorem, because those are my two sides. So negative 10 squared plus 4 squared would equal c squared. So 100 plus 16, so 116. So we take the square root of 116. Which that gives us about 10.77. So our base, 10.77. So 1/2 times 10.77 times our height, which is what we've got to figure out. So to do that, we find our equation right here. So my slope was negative 5/2 times x minus, and let's pick this point, 2, equals y minus a negative 4. That's plus y plus 4 equals negative 5/2 x. Negative 5/2 times negative 2 gives us a positive 5. Subtract 4. We get y equals negative 5/2 x plus 1. Okay, that's this equation. Now for my red equation, we find the perpendicular line that goes through 3, 1. So a slope of negative 5/2 would become positive 2/5. So y minus 1 equals 2/5, our perpendicular slope, times x minus 3. Okay, so y minus 1 equals 2/5 x when we distribute. Then 2 times negative 3 is negative 6 over 5. And we add 1, which I would think of that as 5 over 5, because that's 1. So we get y equals 2/5 x. Negative 6 plus 5 would be negative 1/5. Okay. Now I need to take this and set it equal to this to find out this point. So 2/5 x minus 1/5 equals negative 5/2 x plus 1. So add 1/5. Change this 1 to 5 over 5 because that's the same thing. We'd have 6/5 equals negative 5/2 x plus, and we'd have 2/5 x. So add a 5/2 x. So 5/2 plus 2/5. So I times this side by 2, we get 4/10. This side by 5, we get 25/10. We get 29/10. So 29/10 x equals 6/5. Now, here's something cool. If I times everything, both sides by 10 actually, we get 29x equals 6 times 10 is 60, divided by 5 would give us 12. Divide by 29, and these look like really ugly numbers. So I get 12 over 29, which is very ugly for an x value. That is horrible. This can't be right. Should this have been a right angle as well? But no, it didn't work out that way. Right? Ugh. Because that's like 0.4. 0.413793. So we take that x value, plug it into one of these y values, or this x, we'll go with this one. So I get y equals 2/5 times 0.413793 minus 1/5. So I type that into my calculator. 2/5 times 0.413793 minus 1/5. And we get negative 0.034483. Ugh. So a point of 0.41, negative 0.03. So that point would be 0.41, negative 0.03. Then using the distance formula, we go 1 minus negative 0.03 squared plus 3 minus 0.41 squared. So 1.03 squared plus 3 minus 0.41, so 2.59 squared. 1.03 squared is 1.0609 plus 2.59 squared equals 6.7081. Add those two together, I get about 7.769, which we take the square root of that, and that's going to be our height. That number right there. About 2.787, so let's say 2.88. 2.88 times 10.77 times 1/2. We get 15.5. See how close we are. Hey, there's one for 15. We'll take it. That was an ugly one, wasn't it? Alright, I have a feeling we're going to have another ugly one. So a landscaper plotted the design of a triangular garden on a coordinate plane with each box representing 1 foot. The edging for the garden comes in 6-foot rolls. What is the least number of rolls of edging the landscaper needs to go around the perimeter of the garden? So let's find the perimeter. I'm going to use triangles here because we have a nicer thing. So we go up 1, 2, 3, 4, 5, 6, 7, 8. And to the right, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So we have a slope there of 1, 8 over 8. Okay. So AB slope is 8 over 8, or 1. Okay, now let's do this one. So we go down 1, 2, 3, 4, so negative 4. To the right, 1, 2, 3, 4. So we have a slope here, AC, would be negative 4 over 4, which is negative 1. Hey, now here's the thing. These are perpendicular. 1 and negative 1. That's a right triangle right there. That could save us a lot of work. Because of B, it says calculate the amount of ground cloth needed. So what would be the area? So I'd find those distances. So I'd go 8 squared plus 8 squared equals C squared. So 64 plus 64. So that would be 128. So we take the square root of that, and we get about 11.31. Would be that length. Okay. So then we'd go negative 4 squared plus 4 squared equals C squared. So 16 plus 16. So 32 equals C squared. So then we take the square root of that, and we get about 5.66 for that length. Okay, so for our area here, it's simply 1/2 times that 11.31 times 5.66. So for our area, 11.31 times 5.66 times 1/2. We get about 32.0076, so we'll say 32 feet, right? Because we're dealing with feet. Yep, squared. That's how much ground cloth we would need. Slightly more than that, but we won't get into that necessarily. Okay, so that was the B part. That was easy enough. Okay, now we also need to find this length. Okay, so we're using the distance formula to practice that one more time. Y value of 1 minus y value of 13 squared plus x value of 1 minus x value of the other squared. So we'd get negative 12 squared plus negative 4 squared. So 144 plus 16 would be 160. So the square root of 160 should be about 12.65 for that length. So 12.65 plus 11.31 plus 5.66. Add those all up. We'd have 2 here. 12, 16. Be 4 and 5 would be 9. So about 29.62 would be feet, would be our perimeter. Now they come in 6-foot rolls, so we need to bump that up to 30. So we need 5 6-foot rolls. So that's the number of rolls we would need to get that to work. And, whew, these last problems were difficult. Good thing we won't be having to worry about them so much on the test. Alright, well there we go.